All right, so we're looking at the quiz review of systems of inequalities. And so I'm just going to start from the top and I will work through each one. If you have questions, feel free to ask. So looking here, I have x is less than 2 as my first equation. And like I've mentioned in class, I think it's a good idea to graph each of these equations separately all the way through, and then at the very end identify your solution, rather than like trying to do bits and pieces of each and then shade everything at the end. I think that's confusing. So I'm just going to do one at a time. X is less than 2, and so you may notice here our first step would be to get this in slope-intercept form, y equals mx plus b, but there isn't even a y. So this clues me in that this is a special kind of line. And since it has an x, it's a vertical line. So vux is what I'm going to remember for this. A vertical line goes straight up and down. And my point here is 2. So at 2, 1, 2, I'm going to have a vertical line. Before I draw that line, I want to know if I'm going to do it dotted or solid. This is x is less than. Since it's not less than or equal to, it's going to be a dotted line, which means it does not include points that are on it. It's like the open dot idea that we learned at the beginning of the year. So that's my vertical line at 2, and then it says x is less than. Now since there's no y, I'm not asking if I'm shading up or down. For this one, I'm going to shade left or right. So if x is less, that means my shading is going to go to the left. So I'm going to shade this way. And then I am all done with that first one. So I'm moving on to my second equation. I need it to be in slope-intercept form, so I'm going to get the y by itself. I can add x to both sides, and I'm left with y is less than or equal to x plus 2. So in order to graph this, I want to identify my slope and my intercept. My intercept here is 2, so that's where I'll put my starting point on the graph at positive 2. And I have a slope of 1, which you can't see because it's just x, which means I'm going to go up 1 over 1 from this point. So this is what my line will look like. And then I look at the inequality symbol. It's y is less than or equal to. So since it has the or equal to, I'm going to do a solid line here. And since y is less than, it's going to go down. And this is something I just started doing in these videos, is like when I look up here and look at my shading, I know some people are struggling a lot with the shading. Just go ahead when you get to this point of y is less than, y is greater than, draw an up arrow or a down arrow, and then I think it might be easier for you to know where you're shading. So now I just look for the overlap, which is in this region here, if you can see this area. And so that's my solution. Put a big S there. All right, moving on to the second one. Okay, I have x plus y is less than or equal to 1. I need to get y by itself. Whoops. So I'm going to subtract the x from both sides. So a lot of people have just been doing this and then like moving straight onto the graphing. Please rewrite the equation. Do not be sloppy and miss steps, because I think there's some confusion happening from that. From this point, I'm just going to identify my slope and my intercept. My intercept is -1. My slope is also -1. That means my starting point is going to be on the y-axis at -1. And my slope is going to go down 1 over 1. So from this point, I'm going down 1 over 1 in this direction. And then up in this direction. Since y is less than or equal to, my line will be solid. Since y is less than, my shading will go down. All right, so that's the first line completely done. I'm going to go to the second line. Once again, I've got to get the y by itself, so I'm going to subtract x from both sides. I get y is greater than or equal to -x plus 3. My intercept is 3, and my slope is -1. I can already tell these are going to be parallel lines. So I put my starting point up here, go down 1 over 1, just like my first line. Because it's greater than or equal to, I'm going to have a solid line here. And since y is greater, I'm going to shade up. All right, in this case, I can see that there's actually no overlap, so my solution is no solution. You can draw a 0 with a line through it, a slash through it, or just write no solution. Okay, next one. This top equation, y minus x is greater than or equal to 4. I need y by itself, so I'm going to add x to both sides because it was negative. I'm left with y is greater than x plus 4, where my intercept is 4 and my slope is 1. So I'm going to start on positive 4 and go up 1 over 1. That takes me off the graph, so I need to continue down this way. Because my inequality is greater than without an equal to, it's going to be a dashed line. And since y is greater, I'm going to shade up. Like I said, I think it is really helpful to draw those arrows before you start shading, just to know which direction you're going. So now I'm going to look at the second equation. Once again, need to get y by itself. I'm going to subtract x this time. So I have y is greater than negative x plus 2. My intercept is 2. My slope is negative 1, so that'll be down 1 over 1. Starting at 2, I'm going to go down 1 over 1 this direction. That point was off. Up 1 over 1 this direction. Since y is greater than, there's no equal to, it's going to be a dashed line. So these are both dashed lines. And since y is greater, I'm shading up, just this way. So you can pretty clearly see that our solution area is right up here. So I'm going to label that with an S. Okay, moving on to number 4. This one is already in slope-intercept form, so I can just go ahead and start graphing. I have an intercept at 1 and a slope of 1. So I'm going to start here, and I'm going to go up 1 over 1. And continue down this way. Y is greater than, so it's dashed. And since y is greater than, it's shaded up. Y gets bigger as it goes up. Next line. Also in slope-intercept form already, which is nice. I'm going to start at the same point 1, and I'm going to this time go down 1 over 1. Be careful with those negatives. You've got to go down. So starting at 1, I'm going down 1 over 1 like this, and up in this direction. Since y is greater than or equal to, this is a solid line. And since y is greater than, I'm shading up. So the overlapping area is this top part right here. I'll label it with an S. Okay, next one. This is also in slope-intercept form, which is good. My intercept is 2 and my slope is negative 1. So I'm going to start at 2, and I'm going to go down 1 over 1. For a negative slope, it should be going down and then up this way. Since y is greater than or equal to, it's a solid line. And since y is greater than, it's going up. For the second one here, it's also in slope-intercept form. I have an intercept at negative 2 and a slope of 2. So I'm going to start down here at negative 2. Positive, a slope of 2 means I'm going to go up 2 over 1. And down 2, down 2 over 1. Since y is less than, it's just a dotted line. And since y is less than, I'm shading down below the line. So now I can see my solution is over here to the right, and I'll mark it with an S. Okay. Number 6, y is less than 2x plus 4. My intercept is 4 and my slope is 2. So I'm going to start up here, 1, 2, 3, 4, and go up 2 over 1, which takes me off the graph. So to continue that line, I've got to go back it up, go down and over this way. Since y is less than, this is going to be dotted. And since y is less than, I'm going to shade down. For my second line, I have a intercept at 1 and a slope of 1. So I'm going to start at 1, and I'm going to go up 1 over 1 this way, and down 1 over 1 this way. Since y is greater than or equal to, this is a solid line. And since y is greater than, I'm going up with my shading. So the solution area is in here, this little sliver. All right, down here we are writing, we're given the graph, and this time we are actually writing the inequalities for ourselves. So I didn't explicitly teach this, but it seemed like a lot of people were had a pretty intuitive way of figuring this out. So what I do is I start, just one line at a time. I'll call this my pink line, and I just want to first find m and b. So kind of working our way backwards. My intercept is 2, and you could even kind of take notes. So b is 2. From that point, I'm going up 1 over 1, so my slope is 1. So now I have m and b. I can go ahead and plug that in using my y. But before I do my inequality, I need to decide if it's going up or down. Well, the shading is clearly going down for this one. So y would have to be less than, and the line is solid, so less than or equal to, and then I just fill in my m and my b. So m is 1, so x plus 2. That would be the first inequality of this top line. My second line right here has a intercept at -3, and it has a slope of up 1 over 1, so also a slope of 1. The shading for this one is going up so that it intersects with the other one. And so when I do y in this case would be greater than, the line is solid, so greater than or equal to, and then I have mx plus b, so x minus 3. That's my second equation. Or inequality, sorry. So I'm going to use kind of that same process moving forward. So these I can tell they're both dotted lines, so they're both going to be greater than or less than. There's not going to be any equal to. They also both have their intercept at the origin. So that means I'm not going to have a b. B is going to be 0 for both of these lines. So if I look at this one first, I'll call this my pink line. B is 0, and m is up 1 over 1. M is 1. So when I plug this in, I have y is, now it's shaded up because that's where my solution area is. So y is greater than mx plus b. So 1x, or just x plus b, which is 0. So it's just y is greater than x. That's my first line. And then for this line, it's basically the same thing as just going down. So b is 0, but m is going down 1 over 1, so it's -1. So y, and once again, my shading is up in the solution zone, so it's y is greater than mx would be -x plus b, which is 0. So I can just say y is greater than -x. So that is my second line. And finally, looking at number 9, I'll start with the horizontal line. So this line here, it's dotted and it's horizontal. So if I think about hoi vux, a horizontal line is going to be y, a y line. So y, my shading is going down, so y is less than, it's dotted, so just less than, not equal to. Y is less than, and this point is 1. So that's my first inequality. And then this line right here has an intercept at 1, so b equals 1. My slope is up 1 over 1, so m is 1. So y, my shading is above the line, so is greater than or equal to, because it's solid, mx plus b. So 1x, or just x, plus 1. All right, so that is all for the first page, and all we've got left are a couple inequalities on the back. Okay. So taking a look at number 10, and I'll say right away if you want to work ahead on this, this one's going to be set up similarly to the one on the guided notes that we did. So it says, Diego started an exercise program in which each week he works out at the gym from 4.5 to 6 hours. Whoops. He works out from 4.5 to 6 hours and walks from 9 to 12 miles. It says, make a graph to show the number of hours Diego works out at the gym and the number of miles he walks per week. So if we look at the graph that's given, we have walking on the y-axis and the gym on the x-axis. Now, in both of these cases, we're just kind of given a range. And so this is, like I said, this is really similar to the one we did on the guided notes, where we're not really writing equations here. We're just giving two like ranges. So first, I'll give the range for the gym in hours. So he's working out at the gym from 4.5 to 6 hours. So 4.5 is between 4 and 5. 6 is right here. So this is the time range where he is working out at the gym, between 4.5 and 6 in this zone. All right. And the next time frame we're given, he's walking, which is on this axis, 9 to 12 miles, and this is in miles. So I'm going to fill in from 9, which is between 8 and 10. So between 9 and 12. I'm going to fill this in. So that's my graph. And then we want to list 3 possible combinations of working out and walking that meet Diego's goals. So his ideal range is to be in this area where the 2 graphs overlap. This is his goal. So in answering this question, you just want to pick 3 points that are within that range. So it really, there's tons of answers you could pick, but I could go ahead and pick 4.5 hours at the gym and 10 miles. So I could use that, put that as a point, 4.5 comma 10. He goes to the gym for 4.5 hours and walks 10 miles. That is in his good zone. Also, we could go to 5 comma 11. That would work. If he goes to the gym for 5 hours and walks 11 miles, that's in his range. And if I go to the upper range here of 6 comma 12, that would also be in his range. That would actually be his maximum of both. So there's a lot of different numbers that you could choose. Just make sure you're choosing something in that overlapping area. And I just realized that I put these in the wrong spot. Actually want these to be down here. Okay, so now we're going to do the second word problem. Now this one is one where we're going to actually come up with some equations or inequalities. So it says Emily wants to buy turquoise stones on her trip to New Mexico to give to at least 4 of her friends. The gift shop sells stones for either $4 or $6 per stone. Emily has no more than $30 to spend. And over here I noticed that we have $4 stones and $6 stones. So basically she can pick, the stones she wants for her friends. And so if I'm looking here, $4 stones are X and $6 stones are Y. So I'm going to label that over here as well. So this is going to be one of those ones, and we've done a few of these, and I hope we're getting a good feel for it, where we have one equation that talks about like the amount of stuff, and then the second equation is going to talk about like how much that stuff costs or the value of this stuff. So for the first one, I'm just talking about the number of things she's buying, which are stones. But there's 2 types of stones. There's the cheaper stones, which are $4, and the $6 stones. And she's buying at least 4 because she's buying them for at least 4 of her friends. So the stones she can buy are X, the $4 stones, and Y. And the total amount of stones she's buying, whatever they might be, is going to be greater than or equal to 4, because that means the amount of stones she buys, she's going to buy 4 minimum, but she may buy more than 4. So this number is going to be greater than or equal to 4. For our second equation here, we want to talk about the cost because she also has a budget. She can spend no more than $30. So the stones that are X are $4. So 4X plus these $6 stones would be 6Y. This is talking about the amount she's spending. So this gives me the amount of the cheaper stones, the amount of money she's spending on the more expensive stone. This has to be less than or equal to $30. She cannot spend more than $30. So this talks about the cost. So now that I have two equations, I can just graph them and find the solution area. So x plus y is greater than or equal to 4. I can just subtract x, from both sides, and I get y is greater than or equal to negative x plus 4, where 4 is my intercept and negative 1 is the slope. So I'm going to start over here on 4, and I'm going to go down 1 over 1. And this is a solid line. And if y is greater than this, that means that my shading is actually going to go up. All right, for my second line, I want to move the x to the other side, so I'm going to subtract 4x. And I get 6y is less than or equal to negative 4x plus 30. When I divide both sides by 6, I get y is less than or equal to, 4 and 6 are both divisible by 2, so I get negative 2 over 3x plus 5. So I'm going to start on 5 and go down 2 over 3 for my slope. Starting on 5, I'm going to go down 2 over 3, down 2 over 3, down 2 over 3, that would take me off of the graph. So I'm just going to, is this right? Divide by 2, 4 divided by 2 is 2, 6 divided by 2 is 3. Yeah, that's right. And from 5, 6 times 5 is 30, down 2 over 3, down 2 over 3. Okay, so here's my line. Okay, and for this one, y is less than, so I'm actually going to be shading down below this line. So that means that my answer is in this area right here, where the pink line is representing the amount of gifts she's buying. So she has a minimum amount of gifts she wants to buy, but she also has a budget, which is the green line, which is kind of limiting how much she can spend. So we want to pick 3 points, 3 possible solutions that are within there. So she could buy one $4 stone and 4 $6 stone. So 1 comma 6. Is that, no, that's not right. 1 comma 4, sorry. Which if you add those together, she's getting 4 plus 1. She's getting 5 total gifts if she buys, 1 and 4. Another point would be 2 comma 1, 2, 3. So 2 comma 3 is also in that zone. That would give her a total also of 5. And she could also get 3 comma 2, which would give her a total also of 5. She could also buy 6 $4 stones and no $6 stones. So that would allow her to buy 6 gifts if she just buys the cheaper ones. Looks like she could actually probably buy 7 of those cheaper stones if she buys none of the $6 stones. So anyway, there's a lot of different options here. In this situation, we want to stick with whole numbers because buying 4.2 $4 stones doesn't really make sense. You can't buy 0.2 of a stone. So in this case, we do want to stick to